All right, here is question number 7. Question number 7 has A, B, and C parts. Let's begin with A part. We are given this sequence 6, 9, 12, 15, 18, and so on. We are looking for the 99 term and also the nth term. I want to start with n term. Don't worry. Every term, Tn, in an arithmetic progression sequence is given as A, which is the first term, plus n minus 1 multiplied by d, where d stands for the common difference. So let me bring these terms outside. We have A equal to 6. Then let me leave n equal to 99 because we're going to use it to find the first problem here. Then d can be obtained by taking any term here and subtract the term before it. So we can say 9 minus 6, which is equal to 30. So remember, I want to start with Roman number 2. We are looking for nth term, which is the same thing as Tn. This is equal to A, which is the first term 6, plus n minus 1 multiplied by d, which is 3. So from here we have 6 plus 3 times n is 3n, negative 1 times 3 is negative 3, 6 minus 3 is 3, so we have 3n plus 3. If you like, you can factor out 3. Finally, you have 3 bracket n plus 1. Therefore, every term you're looking for in this sequence, all you have to do is to find that term number added to 1 and multiply by 3. So let's solve problem number 1, where we are looking for T99. So what do? This is just equal to 3 multiplied by 99 plus 1. This is equal to 300. Because 99 plus 1 is 100 times 3 is 300. Therefore, the term number 99 is equal to 300. And this is all about the A part. Then the B part, we are asked to differentiate this function y equal to the square root of 1 minus x cubed. We are going to apply chain rule here. So I would like to let u to be equal to the argument here, which is 1 minus x to the power of 3, which implies that du over dx, we're going to differentiate u with respect to x. This is equal to the derivative of 1, which is constant, is 0, and the derivative of negative x to the power of 3. The 3 will multiply, we have negative 3x to the power of 3 minus 1, which is 2. Therefore, y becomes equal to the square root of u because we have let the argument to be equal to u. And this can be written as y equal to u raised to the power of 1 over 2, right? It's the same thing. So from here, we can differentiate y with respect to u. dy on du is equal to 1 over 2. We'll drop down to multiply u. And power of 1 over 2 will subtract 1. We have negative 1 over 2. This is the same thing as saying 1 divided by 2 multiplied by the square root of u. Remember, we are looking for dy over dx, so let's do it here. Dy over dx, this is equal to dy over du multiplied by du over dx. So let's substitute. Dy over du, you can see it here. But remember that u is equal to what? 1 minus x to the power of 3. So we have 1 divided by 2 multiplied by the square root of 1 minus x cubed. Then you multiply that with what? Negative 3x squared. Negative 3x squared. This is dy over dx. Therefore, dy over dx that we are looking for is equal to negative 3x squared divided by 2 multiplied by the square root of 1 minus x cubed. This is just the derivative of y with respect to x. given that y is equal to the square root of 1 minus x cubed. Then the c part, it stated that a curve passes through the point negative 3, 5, and its gradient at any point is given by the function 6x squared plus 10x minus 7. We're asked to find that equation. What should come into your mind after seeing gradient is dy over dx. Therefore, dy over dx is equal to 6x squared plus 10x minus 7. We are looking for that equation, which is in terms of y. So to find y, we are going to integrate both sides. Integrate the left-hand side with respect to x, you have y. You have to integrate the other side, 6x squared plus 10x minus 7 with respect to x. Let's integrate term by term. This power will increase by 1, it becomes 3, and you have to divide by the 3. So you have 6 divided by 3, x to the power of 3 plus. Power of x here naturally is 1, and 1 plus 1 is 2. So we have 10 divided by 2x squared minus. Having a constant, all you have to do is to multiply it with x. So we have 7x plus the constant of integration. Remember, y equal to this. So let's further break it down. We have y equal to 6 divided by 3 is 2x to the power of 3 plus 10 divided by 2 is 5x squared, then minus 7x plus c. So this is the equation of the curve, but the only thing we're going to find here is c. And how can we find it? By substituting the point we have, negative 3, 5, where x equal to negative 3 and y equal to 5. So we have 5 equal to 2 multiplied by negative 3 to the third power plus 5 multiplied by negative 3 to the second power minus 7 multiplied by negative 3, then plus c. Let's simplify this. Negative 3 to the third power is negative 27, and negative 27 times 2 is negative 54. So 5 equal to negative 54 plus negative 3 squared is 9, and 9 times 5 is 45. Then minus minus is plus, 7 times 3 is 21, then plus c. We have 45 plus 21, which is 66, and 66 minus 54 is equal to 12. Therefore 5 is equal to 12 plus c. Finally, c is equal to 5 minus 12, c equal to negative 7. So having obtained the value of c as negative 7, we are going to substitute it back into this equation. All right, here is the equation. All we have to do is to remove c and add negative 7. And hence, this is the equation of the curve we are looking for. And this is all about question number 7. Now let us move on to question number 8.